Hi guys, my name is Ernest and this is Ernest Sciences and Mathematics TV channel. I'd like to welcome all our members to the discussion for today. We're going to look at the concept of capacitors and how we can represent them in various circuit arrangements. So in this specific case, I'm going to look at a set of two arrangements which are going to assist us analyze the various amount of perhaps current and voltage and other aspects which we're going to be looking at in this specific arrangement. Now we're going to see the relationship between various arrangement of capacitors, perhaps in what we refer to as a series connection. So the first arrangement is basically going to be a series connection, and then we shall look at the arrangement of capacitors in a parallel connection given using this second illustration for P. So in this case, it's going to assist us come up with a formula of finding other, of course, finding the concept of the total capacitance for other arrangements which you may come across in our various question sets. And that's going to form our overall discussion or concept for this specific discussion. And in this case, we're going to consider the amount of the potential which is going to flow across this specific circuit for the first one. And we're going to see that for us to find this one, this is going to be given in terms of V, and the V in this particular case is going to be given in terms of the total cumulative potential which is going to flow through the capacitor 1, and then capacitor 2, and capacitor 3. Now this is going to be true for arrangements which are going to be analogous to this first illustration, and therefore we are going to see that the relationship between the potential difference across these capacitors and the charge and the capacitance can be given from our previous discussion. So we have decided that we can represent V in terms of the ratio between charge and the capacitance given using this particular formula. In this case, then therefore we can consider the amount of course, voltage flowing across C1, C2, and C3. And this can be represented in terms of this specific ratio which we have given. So therefore, it's true that we can represent the voltage V1 in terms of the ratio between the charge, which is the total charge divided by C1. Now, in this case, we're going to see that the same amount of charge is going to flow in all the capacitors, and therefore our numerator for this Q is going to be the same. So we're going also to find for V2 equivalent to Q divided by C2, and then we shall have the V3 represented as Q over C3. So I'm going to create a connection between this one and perhaps the second part of this illustration. So we shall have this space for our evaluation. Then I'm going to create a difference between the two. So we're going to see that this is the relationship which we're going to see being witnessed, and therefore we can represent our first equation, which is V in terms of Q and C, whereby we're going to have V given as Q over C1 plus Q over C2 plus Q over C3. But we have decided that we can represent V in terms of Q over all over C, and this generally is going to give us an equation of another nature which we're going to see, or perhaps we can have this one still being simplified to Q into 1 over C1 plus 1 over C2 plus 1 over C3, and then perhaps let's have this one as our equation number 3, and then from this one we're going to have V over Q as a ratio giving us 1 over C1 plus 1 over C2 plus 1 over C3. And if we try to look at this one, the ratio between V and the Q is going to give us 1 over C. So implying 1 over C is equivalent to 1 over C1 plus 1 over C2 plus 1 over C3. So if we try to look at our evaluation from these specific steps, then we can conclude that we can find capacitance which are going to have this specific arrangement given in terms of this specific reciprocal, or just 1 over C equivalent to 1 over C1 plus 1 over C2 plus 1 over C3. So we're going to have this one given as an arrangement for capacitors which have been given perhaps 3 in number. Then we're going to look at a ratio being used for capacitors which are particularly 2 in a circuit. and that's going to form our final bit of this specific representation. But of essence for us, our objective was to find a representation for this specific arrangement of capacitors in this series form, and therefore this is going to give us a formula for evaluating any of this specific arrangement if we come across it in any of our discussions. So that one having been said and done, we're going to look at the second part of this specific arrangement and try to see how we can represent the second arrangement in terms of an evaluation of a specific amount of capacitance which we can use for the parallel, of course, setup or circuit. And in this case, we're going to consider the potential difference of the source, which is going to be equal to the potentials across each capacitor when the switch is going to be closed, especially for the first one. So for the second one, perhaps we can consider the case of this specific switch. So this switch, when the switch is going to be closed, we're going to see that the potential difference of this specific source is going to be equal across each capacitor when the switch is closed. Now in this case, we're going to consider the relationship we had for this specific case for the capacitance, and we decided that we can give this specific ratio using the formula of Q is equivalent to CV. And in this case, sorry for that, in this case, then therefore we can consider the case for these capacitors for the first one for Q1, Q2, and Q3. So for us to represent this specific, of course, charges, then therefore we're going to have this one represented as Q1 is equivalent to C1, and then we're going to have a V, or perhaps we can have this one as a constant V, and then C1, Q2 equivalent to V C2, Q3 is equivalent to V C3 given as such. As we have said that from my previous statement that the potential difference of the source is equal to the potential across each capacitor when the switches are closed, and therefore this is going to form a constant from this specific, of course, discussion or rather a previous statement which I've mentioned. And therefore we are going to see that the charge can be given in terms of the sum of the charge 1, charge 2 plus charge 3. So let's have this one as perhaps our first equation. Then we're going to have this one as our second equation in this particular case. And therefore, from this specific illustration, we can represent the various charges for Q1, Q2, and Q3 in terms of this specific evaluation that we have written. And we are going to find this one as a Q1, which is VC1 plus VC2 plus VC3. So we can have this constant of V brought out for C1 plus C2 plus C3. And this is going to form perhaps our equation number 3. So the ratio between Q over V is going to give us C1 plus C2 plus C3. But we have said that Q over V is going to be, Q over V is going to be equivalent to C. So therefore we can have this equation of course written in terms of C is equivalent to C1 plus C2 plus C3. So for a parallel circuit representation, we're going to have that specific equation which is going to represent the total capacitance of that specific arrangement. And that is going to be true for capacitors, of course, which are going to be assuming that specific form. So from our initial illustration, then therefore we can have this one represented as 1 over C is equivalent to 1 over C1 plus 1 over C2 plus 1 over C3, which is going to form also our final representation for arrangement of, of course, these specific capacitors in terms of series and parallel respectively. So in case we come across them, then therefore we can evaluate this specific capacitance, effective capacitance, using this the various formula which we have used for the two. And that's going to form our final bit of this specific discussion. But I'm going to put a link of other videos, perhaps, which we can do in terms of an evaluation in our as a playlist in our comments, in our description, of course, box. And that is going to assist us understand the whole aspect of a concept in arrangement of capacitors in a circuit, either in terms of a series or a parallel or a combination of the two. So that is it for now, guys. By God bless you. Catch us in our next video.